James here, and today I'm going to attempt to turn on a light. So this is an electromagnetism box that has 18 experiments, and each day we're going to be doing an experiment, one experiment each day. And also, this is the manual, but we don't need that. Okay, I didn't need that. Okay, I'm back now. And I've read the whole thing. I do not remember it. So, back to the thing. Ding-a-ling what we're doing. Today we're going to be doing the first experiment, chapter 1, getting a light bulb to light. So yeah. The items we're going to need for this are a AA battery, one light bulb, and one wire. Now to get it. The light bulb. The wires. Now for the battery. Where's the battery? And now, since the battery isn't in here, I gotta go get another one. And now I've got the battery. Get the light bulb out. Light bulb. Now, what wire do we need? The light bulb. We need a red wire. There.
Put it in the fast.
We got the wire, and we got the thingy, this thingy. So yeah.
Put the rest of it away.
Oh yeah. And now, since we got the items, I need to reload. Try to find as many ways as possible to get the light bulb to light. Okay. No. Actually, maybe we do light bulb. So there we go, and wow. That did not work, so let's try the next thing. That's not working. How do you do this? Something doesn't work.
She said this is 2 ways to get the light bulb to work. Wait, I think it's in the wrong spot.
And then do that. Oh, like recycling.
Okay. Do the other way.
We finally done it!
Okay.
Let's do this. How do I do it again? I'll just get up there. It's either one touches or the other one. How did you see it?
Like I'll turn off the light.
Yeah. Ooh, the battery's warm. Now's this party.
Alright.
So we've gotten the 3 ways it doesn't work, the 3 ways it no work, and the 2 ways it does work. Yeah. Conditions seemed. Aha, yes. How did you know if electric current was flowing? The light bulb turned on, and also the battery got really hot. And question number 2: what do your diagrams of the lit bulb have in common? Well, basically they both were in the same shape, just the battery was in opposite directions. It was in opposite sides. So yeah. Have anything circular about them in a loop so that the electricity can't go around and it won't just stop. And then from your observations, what conditions seem to be necessary in order for the bulb to light? It has to be in a loop to get the electricity to circulate and get the light bulb to bling.
Now we will go over some background information about this experiment.
And now, Science Corner!
Get the light bulb to work, as seen in this diagram. The electric current. A flow of charged particles is an electric current. We conveniently use I, short for intensity, to represent the current. The current, I, is measured in amps. The unit for current is named after French scientist André-Marie Ampère. An object can store energy as the result of its position. For example, a heavy ball is storing energy when it is held at an elevated position. This stored energy of position is referred to as potential energy. When you release the ball from a certain height above the ground where the potential is higher, it will drop automatically to the ground where the potential is lower. There's a picture of that. Similarly, charges flow from the conductor at higher potential to the one at the lower potential. The flow continues until there is no potential difference between the two conductors. In figure 1.3a, two conductors, A and B, are connected by a wire conductor C. Charges flow from the higher potential difference of B to A through C. The flow stops when the potential difference between A, B, and C is 0. You could maintain the electrical potential difference between B and A by pumping particles from A back to B as illustrated in figure 1-3. B. The charges in figure 1-3b move around a closed loop cycling from the pump to B through C and A and back to the pump. Any closed loop or conducting path allowing electric charges to flow called an electric circuit. An electric circuit includes a charged pump, in this experiment, the battery, which increases the potential energy of the charges flowing from A to B, and a device, in this experiment, the light bulb, that reduces the potential energy of the charge flowing from B to A, and of course conductors, in this experiment, the wire, which allow the charges to flow. Here's figure 1-3. Conventional current is defined as positive charges flowing from the positive plate to the negative plate. A generator pumps the positive charges back to the positive plate and maintains the current B. In most metals, negatively charged electrons actually flow from the negative to the positive plate, creating the appearance of positive charges that are moving in the opposite direction. That concludes chapter 1.
And we figured out that you have to have a summarization situation. Basically what we've done today was try to make this light bulb light. Oh, that's hot. And we figured out that you have to have a circularization to make the light bulb light. Basically this. It's fun doing it. Make sure to like, comment, and subscribe below. And thank Marsh Arts for helping me with. Thanks for watching. Make sure to like, comment, and subscribe below. And Tiger James out. So there's no battery, so I just... It is?
Yeah.
Hi. Hey. La da da da.
What is happening? Oh, you completely unplugged it from the wall. There we go.
Everything?